Welcome, ladies and gentlemen, to the Environmental Community of Interest titled USACE Engineer Research and Development Center, ERDC, Emerging Capabilities and Programs. I am Tamel Harbison with SAME National Team, and I will assist with any technical issues you might experience. Before we get started, I would like to go over a couple of housekeeping notes. You have entered the platform in a listen-only mode, but we ask that you double check your microphones to make sure that they are muted. If you have any questions throughout the presentation, we ask that you submit those in the Q&A tab in your toolbar. You are able to download today's presentation and PDH certificate in the handout section as well. That's located in your toolbar. This webinar will be recorded and posted on the Environmental COI webpage at a later date. And without further ado, I would like to turn it over to our moderator today, Jane Huber.
Thanks, Tamel, and thanks for joining us today. We have a really interesting presentation. Wanted to ask everyone to list your questions in the Q&A section, as Tamel said, and we will do those at the end of the presentation. And I will, if there's a question for a particular speaker, please indicate that when you submit the question. Otherwise, we'll just ask the group. The environmental COI, when you can go to our web link at SAME to download the presentation and PDF for attending the session. And our first poll question is which part of the military or which part of the SAME organization do you represent? Are you part of the military? Are you civilian government agency, small, medium, or large business, or academic? So if you can submit that, that just tells us who's online. Okay. And our first speaker will be Dr. Edmond Russo. Dr. Russo currently serves as the director of the Environmental Laboratory for the U.S. Army Engineer Research and Development Center, ERDC. It's a position that he assumed in September of 2020. Dr. Russo leads the laboratory in providing relevant value-added technologies supporting the environmental mission of the U.S. Army Corps of Engineers, the U.S. Army, Department of Defense, and the nation. The laboratory's interdisciplinary staff has over 250 engineers, scientists, technicians, and support personnel. They do everything from basic research to implementation to commercialization of new technologies. Partners with federal and state agencies, academia, and the private sector. A really, really interesting part of the Army, and I'll let you take over, Dr. Russo. Thank you.
Okay, thanks everybody. Appreciate the opportunity to present to you. This is an overview of the ERDC Engineer Research and Development Center and the Environmental Laboratory, EL. The Engineer Research and Development Center is composed of 7 laboratories. It has an annual research program of over $1 billion and over 2,000 employees at these laboratories. This map here shows the locations of the laboratories in the United States and also a location of our International Research Office in London, England. There are 4 laboratories in Vicksburg, Mississippi: the Coastal and Hydraulics Laboratory, the Environmental Laboratory, the Information Technology Laboratory, and the Geotechnical and Structures Laboratory. The Construction Engineering Research Laboratory is located in Champaign, Illinois. The Cold Regions Research and Engineering Laboratory is located in Hanover, New Hampshire, and the Geospatial Research Laboratory is located in Alexandria, Virginia. The red dots that you see signify locations of field offices that the laboratories have across the United States. In the ERDC, we have over 55% of our employees in engineering and science discipline positions, 3/4 of which have advanced degrees, and over one or close to 1/3 have doctorate degrees. In the ERDC, we have several different research and development areas. Of note, the slides are jumbled, some of the text in here, but when you download the handouts, you should be able to see the slide graphics a little more properly configured, but we'll go with it. The first research and development area that I'd like to talk about is the military engineering RDA. It is for innovative technologies and capabilities to enable force protection, force projection, maneuver, and maneuver support to enable multi-domain operations, or MDO. The Civil Works RDA is about creating innovative and environmentally sustainable solutions to water resources challenges in navigation, flood and coastal risk reduction, and environmental, hydropower, and water supply business lines. In our Installations and Operational Environments RDA, we produce cutting-edge solutions for installations, training ranges, and contingency basing for environmental sustainability and energy security, for understanding the environment, detecting hazards, and mitigating negative impacts on soldiers, as well as operations in urban landscapes, industrial complexes, and subterranean spaces. In our Geospatial Research and Engineering RDA, we do mapping, geospatial analysis, and mission planning technologies to ensure superior situational awareness of the operational environment for the warfighter and to enable mission command. In engineered resilient systems, we advance engineering techniques at high-performance computing platforms to develop concepts and tools to significantly amplify design options examined during early stages of the Department of Defense weapons system acquisition process. Here are the ERDC's top 10 strategic science and technology focus areas that we apply to advance the research development areas. The first of which is enabling multi-domain operations. Multi-domain operations is covered by the MDO strategy, which you can find online, and it basically talks about integrating the full spectrum of space, cyber, air, land, and sea operations of the joint military forces to conduct military operations. So enabling MDO at ERDC is in support of Army modernization priorities and to enhance future warfighter mission command and readiness, logistics, force projection and maneuver support, intelligence, sustainment, and force projection. In our S&C focus area for revolutionizing civil works, we address comprehensive hydroterrestrial risk management. We advance next generation water resources infrastructure. We conduct innovation in sediment management. We also conduct sustainable species management, as well as crisis mitigation and response. That all supported by data science and artificial intelligence. For enabling smart and resilient installations, those as resilient power projection nodes, environmental sustainment for ranges and lands, energy and cybersecurity, and facilities modernization is supported by our science and technology. Accelerating digital engineering is conducted through our S&T by leveraging data science, artificial intelligence, machine learning, trade space analytics, physics-based models and simulations, and high-performance computing. For understanding and adapting to extreme environments, we do that to enable understanding of these environments and their processes to predict near and long-term climate and societal impacts, and to shape adaptive strategies and solutions. In developing robotics and autonomous system capabilities, we apply S&T to enhance emerging perception, interaction, and geolocation within the operational environment through accurate digital and physical representations to ensure sensor platforms properly understand the complex world with predictive system behavior. In modernization of national security, engineering, and emergency response, we advance science and technology to provide innovative solutions for all echelons of government against natural, physical, cyber, chemical, and biological, as well as nuclear threats. In the process of unifying sensing, intelligence, geospatial engineering, mission planning, and contingency operation functions, we advance science and technology to provide seamless 3D geospatial information for map-based planning with continuous reanalysis and updates at brigade and below. For advanced material and engineered systems, we conduct S&T to develop novel material solutions that enable rapid deployment of expeditionary structures for force protection, protective shelter and infrastructure materials, hardened structures, and resilient infrastructure systems. And last but not least, for ensuring resilient and sustainable ecosystems, we advance S&T through technologies that improve the resilience, health, and sustainability of ecosystems through innovative detection, modeling and simulation, testing, risk mitigation, cleanup, restoration, and environmental remediation techniques. So in the environmental lab, we're all about, in our vision and our mission, delivering innovative solutions to tomorrow's environmental challenges by broadening the spectrum of benefits, improving quality, lowering costs, shortening time frames to delivery, and reducing levels of effort. And at the end of the day, we maximize the Corps of Engineers and Army's operations in the environment. It's because we understand the environment and we know how to discover anything about it that isn't known to advance the Army and Corps of Engineers operations in the environment. This is just a little breakdown of the environmental laboratory. You can see that millennials make up a good portion of our workforce, and that most of our workforce is engineering and scientists, E&S. We're broken down almost 50-50 in terms of male and female, in terms of gender. We have a large amount of doctorate and master's degrees employees in our organization. And the years of experience generally are centered around mid-careerists, anywhere between 10 and 20 years are where many are falling in terms of their years of service. And we have many different environmental disciplines in science and engineering that make up our workforce of about 270 employees as of the end of 2020. So what drives our mission in Environmental Lab and in the Engineer Research and Development Center? We look at strategic documents that are available online in the Army and in the Corps of Engineers for both military and civil works mission areas. And so we take those cues anywhere from a national defense strategy to any of the other strategies shown there to anticipate the capability gaps in mission execution for the Army and for the Corps of Engineers to be successful in seamlessly executing according to expectations in our goals and objectives. By and large, the National Defense Strategy discusses the concern that both Russia and China pose an emerging threat in contested environments that we need to be aware of and ensure that we're planning for tomorrow through the Army Modernization Strategy, the MDO Strategy, the Army Installation Strategy, and Arctic Dominance Strategy. Again, the MDO I described already. That's a coordinated network across all forces in space, cyber, air, land, and sea. That is reinforced by the Army modernization strategy, which is comprised of cross-functional teams that look at improving long-range precision fires, next-generation combat vehicles, future vertical lift platforms, advanced technological networks, air and missile defense capabilities, as well as soldier lethality. And that is all aligned with the Army installation strategy to ensure that we have a line of sight to Army modernization and MDO. And the Army installation strategy at the end of the day is focused on a goal of delivering modern, resilient, and sustainable installations as power projection platforms in support of MDO in contested environments, such as the Arctic, which is a new Army strategy that has been published that we take cues from in identifying the gaps and the required research, development, testing, and evaluation to address those gaps for closure. In the Civil Works program, to the lower right, there are a number of areas that we work in to support execution of the Civil Works mission across several business lines consisting of navigation, flood risk management, coastal storm risk management, ecosystem restoration, hydropower, and water supply. And so we advanced science and technologies in those areas to address the issues of climate change stressor drivers, such as relative sea level change, changing legislation, changing resources. We look at aging infrastructure systems, as well as the need for new systems and improved systems. And we also consider many different stressors on those systems as we look at the driver in context of the drivers to understand the long-term adaptive capacity, sustainability, and resilience of these systems to deliver performance as expected for the investments that have been made. In environmental laboratory, this is a summary of our research capabilities around the perimeter that you could see. And really the purpose is to support the Civil Works Water Resources mission, as well as the military mission for the Army, DOD, and other military branches in support of the soldier and our installations in executing the military mission. We really do that across a broad range of science and technological areas, ranging from the micro to the macro, as well as the habitat environment to the human dimension. We perform our research in applications that consist of field and laboratory work, as well as desktop studies and modeling and analysis to deliver these innovations into practice. These are 8 emerging capability areas of the environmental lab. You'll hear about 4 of those today in deep dives by some of our senior researchers, and we're pleased to be able to talk about these areas. We're going to be covering the emerging contaminants, the biotechnology solutions, natural systems resilience, and combating emerging pathogens. This is a breakdown of the organization in the environmental lab. We have the distinct pleasure of having both of our senior scientists, Dr. Todd Bridges and Dr. Ed Perkins, who are on the right-hand side at the top of this graphic, to present today on these key topics, as well as Dr. Igor Linkov, located to the left in the box at the top, who is a senior scientific technical manager. Both Todd and Ed are senior scientists in the laboratory. And of note, there are only about 40 senior scientists in the Army, and we have 2 of the 40 in the environmental laboratory, so we're very proud of that. We also have divisions and branches that house most of the scientists and engineers that perform the technical work in research, development, testing, and evaluation, as well as research, development, and technology areas, both in the military and civil works arenas, respectively. One is the Ecosystem Evaluation and Engineering Division, and the other is the Environmental Processes and Engineering Division. And the branches for those respective divisions are located around the bubbles that they're in here. And so with that, I'd like to transition to our first speaker, I believe will be Dr. Todd Bridges, to cover the first emerging capability area. Thank you for your time.
Thank you, Dr. Russo. That was great. All right, and then we're going to move to Todd Bridges. He's the U.S. Army Senior Research Scientist for Environmental Science. He's been with USACE and ERDC for 28 years, and he leads the USACE Engineering with Nature initiative. It's a really interesting group. So I'll leave it to you, Todd.
Yeah, thank you very much, Jane. It's a pleasure to be here today to talk to you about engineering with nature and how we're using natural systems to deliver mission resilience for the Department of Defense, as well as value to the nation in the context of our civil works program within the Corps of Engineers. I'd like to start by acknowledging, I think, something that probably all of us recognize, and that is that we live truly in a multi-hazard world. If you look at the types of hazards represented on this non-exhaustive list of hazards, there are those hazards that are truly man-made regarding our engineering, as well as those that we consider to be natural hazards, and the majority perhaps being combinations of both man-made and natural. If you consider, for example, on the lower portion of this graph, the 2020 record-setting storm season in the Atlantic, we had 30 named storms, 12 of them, I believe, reached landfall. That's an all-time high that season in recorded history. So when we think about this, if we just consider, say, climate and weather-related hazards, since 1980, there have been 285 events that have produced at least $1 billion in damage as an event. And if you look at the total across that 285 events, the total amount of damage that has been caused to the United States amounts to $1.875 trillion in damage. In addition to that, 14,000 lives lost in those events. I think those two statistics suggest that our approaches to managing natural hazards is not aging well. So with that in mind, when we consider how much infrastructure we have built, particularly in the 20th century in the United States, some of the statistics are on the right. Now, we have built a lot of stuff in all sorts of forms. And I think when we consider the challenges that we're confronting now squarely in the 21st century, one could easily make an argument that our approach to infrastructure engineering is not aging well with respect to natural hazards in general or other issues as well. On the lower right-hand side, I'd like to draw your attention to this graphic that came from an article that was published in Science just this past December, where we reached a milestone in 2020 of some significance, I think, and that is the total amount of human-made mass, largely in the form of materials we use to create and construct infrastructure in the form of concrete, aggregate, brick, asphalt. The amount of human-made mass on the planet in 2020 now exceeds the total living biomass on the planet at more than 1 teraton. That's 1 with 12 zeros behind it. In fact, in the 20th century, the amount of human-made mass in the form of these materials that was produced and put into production, if you will, use, doubled every 20 years. That curve on the right, I really think challenges the whole notion of sustainability. Where's the end of this curve? Is there an end to this curve? especially as we approach a population of probably in excess of 10 billion people on the planet by the end of the century. So when we think about the infrastructure investment that's going to be made in the remainder of the 21st century, and it's going to be a lot of money worldwide, the World Economic Forum estimates by mid-century that $100 trillion will be invested in infrastructure. What is that infrastructure going to look like, and how's it going to operate? That includes the idea of to what degree are we going to include natural systems more explicitly as a part of the infrastructure we developed. And this is one example of what I mean by that, the natural system as infrastructure. Some scientists being supported by the insurance industry used insurance industry tools to estimate the benefits that were provided by mangrove forests in Florida during hurricanes. And they used in particular one hurricane to get to specifics, Hurricane Irma. And their estimate using insurance industry tools and models was that mangroves were responsible for avoiding, if you will, $1.5 billion in flood damages from that one storm. Obviously, if you project that out over the a longer period of time, you can see those numbers adding up significantly. One of the things we're doing at ERDC, and the lower photographs you can see, bringing these systems, physical representations of these systems into our flumes to be able to translate how mangroves, in fact, are functioning, so that can be incorporated into design of future systems. This is one example, what I just showed you, of our Engineering with Nature initiative, which we began formally in 2010. So we celebrated our 10th anniversary last year, where we're seeking a more intentional alignment of the natural and the engineered to realize efficiency, of course, and to be sustainable in our delivery of infrastructure projects. And we emphasize science and engineering to produce efficiencies, using natural processes to maximum benefit, expanding and diversifying the types of benefits we can produce from infrastructure, and being collaborative as we produce these approaches and these solutions. One of our applications is at Tyndall Air Force Base. Many of you are aware that Tyndall Air Force Base was severely damaged during Hurricane Michael in October of 2018. In fact, right now, nearly a $5 billion investment is going into rebuilding Tyndall Air Force Base, and Engineering with Nature is being used to support resilience at that base. Tyndall's, some odd 30 some odd thousand acres of land that it occupies is in a beautifully diverse coastal landscape that you can see represented graphically at the bottom of this slide, in the form of islands and beaches and dunes and back bay environments and wetlands. And we're working now with the Air Force as a team to be able to not only identify opportunities to invest in these natural landscapes and build new ones, but also in the process now of piloting some of these opportunities to contribute to resilience value for the long term for the base itself. If you're interested in learning more about this system in our Engineering with Nature podcast series, Brigadier General Patrice Melanson last year gave an overview of this coastal resilience work and how we're using the natural landscape there to support this system over the long term. I'd also draw your attention to another example of this. DARPA, the Defense Advanced Research Projects Agency, just recently announced this new program called Reef Fence, in which DARPA will be making as much as a $50 million research investment over 5 years on the use of reefs, oyster and coral reefs, to provide this kind of infrastructure engineering function, constructed, if you will, oyster and coral reefs, to reduce coastal flood hazards, to increase coastal resilience as relevant to the Department of Defense. And our organization at ERDC is pleased to be able to provide independent verification and validation for this program. So we're going to be on the ground with these project teams delivering this research over the next 5 years. This is my last slide. There is obviously a range, of outcomes here. There's a spectrum from, on the left, you might consider to be the wild, free-flowing nature, as it may have existed at one point in time, or the tamed and constrained form of nature that we see today. If you could just compare with the Duwamish Waterway or the Duwamish River, what it looked like in the 1800s in the state of Washington on the upper left, with what the Duwamish River looks like today, you can see that's a lot of transformation. That society, that people imposed upon that system with the support and aid of civil engineers. And what we're trying to achieve with engineering with nature is a rebalancing. And we understand we're not going to be able to reverse the time machine and go back to the 1800s and what these systems look like. But we can realize not only more value in the form of social and environmental and engineering value from incorporating nature more explicitly into our infrastructure solutions, but I think we can also at the same time realize more resilience and sustainability for the humans that are supported by that infrastructure. So thank you, and I'll pass it on to the next speaker.
Thank you, Todd. That was really interesting. And I want to check and see, we're double booked for Dr. Perkins. So Ed, are you online, or should we?
I am here. Can you hear me?
Okay, great. Perfect. Okay. Yeah, good. All right. So we've got Dr. Ed Perkins, and look at, he's a senior research scientist for environmental networks and genetic toxicology. Dr. Perkins is the Army Senior Research Scientist for Environmental Networks and Genetic Toxicology, located in the Environmental Laboratory at ERDC in Vicksburg, and he's been there since September of 2009. He's the Army's lead research scientist for toxicology and has published more than 130 journals and articles. He provides guidance to the Army and the DoD and has had multiple national and international awards, including the ERDC Researcher of the Year. So I'll let you take it from here. Dr. Perkins, thank you.
Okay, thank you. So I want to talk about sort of the flip side of what Todd was just talking about. Biotechnology, or about how we can actually engineer nature to do more in the environment for us. Next slide. So I just want to start out with what is biotechnology. Probably heard a lot about it. Basically, biotechnology is an engineering discipline that utilizes or exploits living systems to produce a wide range of technologies and products. And so this is a pretty wide-ranging definition of biotechnology. Within that, you may have heard there's some very topical subgroups of that, one called engineering with biology. It's basically applying what we're now calling synthetic biology. That's where we intentionally design and construct or adapt biological entities to do desired functions, like manufacture chemicals, sense chemicals in the environment, do different things. And then engineering with biology is much like what Todd was talking about, using natural systems and processes for an engineering function. However, in this case, we're mostly talking about fabrication of novel materials and resilient products, or to advance human performance. So I'll touch a little bit base on a little bit of all of these and how they might be used by the Army and in the environment. Next slide. So just to kind of give you an overview of how impactful biotechnology is now, one of the most important inventions has been for biotechnology has been fermentation, and that's as evidenced by evidence from thousands of years ago from the first beer that was produced. So production of wines and fermented drinks is really all about biotechnology and harnessing yeast to help us make more interesting beverages. However, over the next 10, 20 years, we really expect the application area of biotechnology to expand from meats that are produced without animals to medical solutions for monogenic diseases, personalized diets to synthetic silks produced by microbial factories. And some estimates are up to $2 trillion to $4 trillion for the whole world market. And right now, they estimate 60% of the world's physical inputs could be made using biological means, that is, materials and other items. Over the next 20 years, so have this impact of $4 trillion globally per year. The most recent big impact that we've seen has been the rapid development of COVID-19 vaccines and tests. We've had an unprecedented rapid development of vaccines to different strains and varieties of COVID using mRNA technology and a number of different very rapid development of a number of very specific tests for these presence of these viruses in humans and in saliva using biotechnology type tools. Next slide. So how can we use that in the Army? Well, the Army, we're looking at using it in many different areas. We're looking at using biotechnology to make new foods, nutrition regimes, sensors to sense when soldiers are performing well, vaccines and therapeutics, physiological modeling. One big area that you may have heard of is gut and microbiome, where we're trying to make pills that may be able to alter your gut microbiome to enable it to produce chemicals that might help you withstand stress better or manage your strength as during training. On the soldier, we're looking at production of materials such as ballistic, environmental, and eye protection, camouflage, lightweight batteries, uniform sensors for chemical, biological threats, and performance monitoring. Outside the soldier in the environment, where the environmental lab usually plays, is really a lot of different areas now. We're looking at mechanisms where we can have networks of surveillance, sensors using biology, environmental intelligence, designing biology to actually report to us what's happening in the environment by incorporating sort of a logic where it senses a chemical that causes a change in the bacteria, and that can report back to us what it has sensed. Then more traditional things with remediation technologies, trying to develop novel methods for degrading things like PFASs, which are very difficult to get rid of. Then we're also looking at how we can make materials to help the soldier and on the warfighting platforms, such as synthesizing new types of explosives, new types of energy, new materials that can be used to obscure the site or obscure the site of sensors from the adversaries. On-the-spot manufacturing tools that let you actually manufacture drugs or other chemicals out in the field as you need them, and new tools for water purification and remediation. Next slide. So one of the big areas that are kind of non-biomedical is really growing structural materials. And that's where we're starting to get into ideas like engineering living materials, taking things like fungus that might grow very rapidly and using that to grow into structural elements. Here we're talking about biocementation using bacteria to actually create cement. Right now Air Force and ERDC are testing out a product called from the company Biomason that lets you spray bacteria on the ground, as illustrated in the upper right-hand corner. Spray a mix of bacteria and chemicals on the ground and on top of rocks, and then it'll start growing concrete right there. You do that over various layers, and you can start growing concrete, thick layers of concrete that you can actually maybe drive trucks on or land planes on. And the importance of this is that it is very low carbon and takes a lot fewer materials than moving trucks and truckloads of cement materials around into different theaters. Next slide. So really, this is all about changing how we do engineering with nature. So while Todd was engineering with nature in a more natural way, here we're trying to actually really engineer nature to help us do things in the environment. Major areas that we're hoping to start developing products for are infrastructure, expeditionary infrastructure, ways that we can use biology to build structures out on as we're moving through the field on the Army. Self-destructing infrastructures, that is buildings or bridges that might fall apart when you don't need them, so they just sort of disappear. These processes are often low CO2 emission, therefore they don't contribute as much CO2 as all the billions of tons of cement that have been put over the last few years. You can also design these processes for CO2 sequestration. There's methods for developing anti-corrosion, anti-fouling materials using bacteria. And also infrastructure failure can be addressed using this by developing bacteria that can fill cracks. And then self-repairing materials. There's potential for creating concrete embedded with bacteria that can start repairing it as it's being developed. Really, where it can really apply, we think this can apply is engineering nature for resilient infrastructures. We can develop materials such as those in the pictures in the middle, top middle, which is sort of an bacterial polymer with bacteria in it that are aggregating rocks, small rocks together to make a solid substrate. Within that, the bacteria can also produce different substances in reaction to the environment, and that, in essence, becoming smart material and doing different performance behaviors. And the real ideal properties that we're looking at here is really living materials and structures that can adapt to changing conditions on their own. Next slide. So ultimately, this really leads to the fact that we can now create some novel environmental solutions. Design infrastructure to be resilient and interact with the environment. On the left top picture, you can see as a house in Hamburg, Germany, where panels of microalgae absorb sunlight and passively generate energy. There's some during the in the center is a depiction of some of the leeways in the district of New York, I think it was, looking at cracking and self-healing. There's been discoveries of using bacteria that you can put into the cement that will start sealing up these cracks as they start occurring. And then there's on the upper right-hand corner is illustration of using fungi to build buildings. This is using myco bricks from Ecovative to construct this building, and then you can actually have that building start growing over time. We also now have technologies where we can start making resilient wetlands by making them resistant to insects and salt water. Biotechnologies that can eliminate invasive plant species. Trying to make self-cleaning and stress reporting streams by putting bacteria on them that will actually sense chemicals in the environment, destroy them, and tell you the health status of the streams. And one area where that could have some direct applications is really trying to enhance phytoremediations of recalcitrant chemicals, such as at Niagara Falls storage site, which is one engineering with nature project. We can try using engineering nature to help nature do a better job. Next slide. Well, that was the end of my talk, and I just wanted to give you a taste of what biotechnology is and what it can do for you. Thank you.
Okay, thank you, Dr. Perkins. That was really interesting. All right, then our next speaker, I think, should be David Moore. And David had spent 30 plus years as an environmental toxicologist and risk assessor, working both in the public and private sectors, and he currently leads ERDC's Emerging Contaminants program. He also listed that he's a new grandpa, so congratulations. We'll let you take it from here, David.
Well, thank you, Jane. And thank you for having me here today. I'm going to give you a really sort of a brief thumbnail sketch of a program that has evolved over the last couple of years, starting in about late 2017, early 2018. And that is the program for emerging contaminants. I'm going to see if I can advance my own slides here. So let's see how this goes. There we go. So just to provide a bit of background, ERDC as an entity has been dealing with emerging contaminants in one form or another for well over 30 years. And we've developed unique capabilities and expertise to address the range of issues that relate to emerging contaminants. We've looked at things from everything from coal ash to anti-foulant paints like tributyl tin, to more traditional constituents the constituents that we think of as being traditional today, but early on they were new, PCBs and dioxin, to things that are sort of more military unique, like depleted uranium and tungsten and sensitive munitions, and then the new contaminants du jour that include things like microplastics and per and polyfluorinated alkylated substances that relate to both the military's use of aqueous film-forming foams in firefighting operations, as well as a whole slew of industrial applications. In addition, we also, as part of our effort to support the military and in development of advanced materials, we also do sort of due diligence on environmental safety and occupational health perspective, looking at things like new nanomaterials and additive manufacturing. The capabilities sets that we have include analytics, developing new techniques for detection and measurement of various substances in the full range of environmental media, water, soil, sediments, and then biological media. We also look at how those materials reside and move through environmental media, through fate and transport processes. And then we also address, obviously, things like exposure, how it moves out of that media into organisms and up the food web, and then what types of effects it elicits and the nature of those effects. And then finally, once we've identified particular issues, then we're looking to establish how we go about addressing those through various risk management processes, whether it be treatment or remediation or some other form of managing the risk associated with those particular issues. The problem that we encounter looking back with sort of the historical approach to ECs, emerging contaminants, is it's a little bit like whack-a-mole. Often we don't realize that there's a problem until it's actually having a programmatic impact. And as most of the folks on the phone are aware, it takes some time to spin up RDT&E to be able to address those issues. So we find ourselves in a reactive mode where we're responding to rather than actually engaging with or affecting the regulatory environment that we find ourselves in. The second issue is that it's sort of been done piecemeal. The squeaky wheel gets the grease, so to speak. So, for example, on PFAS, the first and highest priority was addressing drinking water on our military installations, because, of course, we want to protect our soldiers. But we're not, thinking broader and more holistically about the fact that there are also large implications on our civil work side for our dredging and navigation mission. And historically, this is no longer the case, thankfully, today, but historically, back in the day when Todd and I started at ERDC 30 some odd years ago, there was limited coordination and collaboration across the laboratories. ERDC was really a collection of entrepreneurial technical experts. We're soft money funded, and folks were out to build their program and support the people that were working for them, and there wasn't a lot of incentive to work together. Well, thankfully, that's no longer the case, but we haven't really availed ourselves of this new collaborative atmosphere from a perspective of dealing with emerging contaminants. And finally, and this is kind of obvious from the previous two issues, is that it's inefficient. It was inefficient. We found ourselves reinventing the wheel. There was no significant corporate repository for basically archiving the expertise and information that we had generated, and sometimes we were finding ourselves repeating things that had been done before in order to address new and emerging issues. So as I mentioned at the outset of the talk, and around 2017, late 2017, early 2018, we developed this program for emerging contaminants. And the thought process here was really to avail ourselves of the capability sets and facilities across the ERDC, thinking back to Dr. Russo's talk of introducing sort of the 7 laboratories and the broad array of technical expertise that we have here at ERDC, and basically creating a coordinated multidisciplinary approach to be able to provide turnkey support for addressing emerging contaminant issues. And this includes things like rapid assessment capabilities, development of new analytical techniques, taking advantage of our high performance computational capabilities through our information technology laboratory to utilize things like advanced computational models that enable us to be able to do a read across, where we might have a lot of information about one set of compounds, and utilizing that information and the chemical structure for compounds that we know less about, we're able to sort of infer potential risk associated with the chemical and physical properties of those compounds. Our ability to be able to do detailed forensic evaluations to identify causal agents and mode of action and understand sort of fate and transport mechanisms. And then finally, our expertise and capabilities on the risk assessment and risk management front, including the ability to be able to do risk identification and prioritization, be able to effectively communicate risk so that folks can understand and develop appropriate management strategies, to developing treatment solutions and remedial strategies. And certainly, as I mentioned earlier, the due diligence aspect of it, having a built-in process for doing the environmental safety and occupational health of new materials that we're generating to be able to support the warfighter in our civil mission. So the one thing that the center is trying to do is avail itself of a whole of ERDC approach in these sort of 4 key topical areas. On the analysis front, we have capabilities within the environmental lab and the cold regions environmental research lab, as well as the geotechnical and structures laboratory. And I should mention also in ITL, where we develop new sensor platforms and whatnot to be able to detect and quantify contaminants across the full spectrum of environmental media: air, water, soil, sediments, biota, and materials. On the exposure side, we have capabilities and expertise in EL and CREL and GSL, our coastal hydraulics lab, as well as the high performance computing capabilities at ITL to enable us to be able to better understand fate and transport mechanisms, uptake and movement through food webs. On the effects into things, we have capabilities, expertise within EL and CREL, and again, supported by the big data capabilities of ITL, and then finally at the risk characterization and management into the spectrum, again, EL, our construction engineering research laboratory, and ITL to provide support on things like computational modeling, life cycle assessment, and treatment and remediation. So not only do we have do we avail ourselves of the expertise within ERDC across our 7 laboratories, we also have mechanisms, vehicles to be able to work with outside entities. So we have everything from intergovernmental agreements and MOAs to work with other federal agencies and as well as within the DoD. We have agreements with a number of academic institutions. We do a lot of work through cooperative research development agreements with private industry, and we have international agreements where we partner with other nations to work on specific issues. So just by way of example, one of the the big contaminants of the day, obviously for DoD and others, is per and polyfluorinated alkylated substances, and we've certainly been doing quite a bit of work on that front. And the thing that I want to convey is that these are not siloed efforts. That a lot of what we learn in the analyses and the exposure front obviously feeds into supporting our understanding of risk and also in developing solutions. So there's a lot of crosswalk that happens, and that's the advantage of having a program, an organized program, to facilitate that exchange of information and foster those kinds of collaborative exchanges of information. So on the analytical front, a couple of things that we're doing is we're developing new analytical methods. Sort of the state of the science for analysis of PFAS is triple quad liquid chromatography, mass spec, and there's the Orbitrap system. The one thing that it enables is it allows us to have higher level of peak discrimination. Many of these things, these PFASs, which we're talking 8,000 homologs, a lot of them co-elute, and so to provide that level of discriminatory power, the Orbitrap it looks to be a promising technology. The problem currently is that we're not able to get the level of detection limits that we need to be able to measure the small quantities in the environment. So we're working on that front to improve those detection limits. We're also working, assisting the Defense Logistic Agency in an assessment of packaging materials for meals ready to eat for our soldiers. The National Defense Authorization Act of 2020 basically mandated that all MREs should be PFAS free. So part of the challenge for DLA is certifying these new replacement packaging materials as being PFAS free. And of course, that's packaging materials are sort of a strange media to work with. How do you do the extraction? How do we certify these things as being PFAS free? What constitutes PFAS free? Et cetera, et cetera. So there's lots of questions and challenges associated with that work. On the exposure front, of course, we're trying to get our arms around, we sort of have an understanding of what our issues are and our challenges are on the military side of the page in terms of the installations in our firefighting training operations and hangar, fire suppression infrastructure, et cetera, et cetera. We don't have as good a handle on what the potential issues are with respect to our civil side in terms of the reservoirs we manage and the sediments that we dredge and et cetera, et cetera. So we're doing some preliminary work to get an understanding of prevalence of which PFASs we see in the environment and utilize that to sort of prioritize research for developing an understanding of risk of sediment-associated PFAS. We have a fate and risk evaluation system for contaminants called Fresco. It was originally developed for tracking munitions and groundwater. We're looking to parameterize that model so that we can better inform groundwater movement of PFAS on installations and elsewhere. On the effects front, we've been doing a lot of work. We have a collaborative agreement with industry that is also co-sponsored by the CERDP program to do a multi-generational exposure looking at the effects of PFAS over 3 generations and trying to understand mode of action. And then that information is actually being fed into another effort, which I'll talk about in a moment, and I'll bring that back up. We also have a CERDP-funded effort evaluating uptake and effects in terrestrial systems. And on the flip side of the coin, I mentioned the NDAA. While it mandated that packaging materials be free in 2021, there's a separate mandate for 2023 that all firefighting foams be PFAS free. And so there's a huge push to look both at commercially available as well as those foams that are under development to make sure we don't have what we call substitution regret, where we're swapping out one problem for another in these new foams. So we're doing the evaluations to hopefully avoid that substitution regret. We also have moving on to the risk characterization and management front. We have a pretty unique effort funded at the DoD Office of Secretary of Defense that is a multi-DoD laboratory effort to develop computational models for rapid risk characterization. So this is basically developing high advanced computational models that avails itself of information that's generated through high throughput type of testing technologies, new approach methodologies, as they like to call them, things like liver on a chip, gill on a chip, and be able to utilize that information to better understand and characterize the 8,000 plus PFAS compounds. And some of the information that we generated as part of that multi-generational study is actually being utilized to parameterize those models. So there's another example of sort of crosswalk between our different programs. We also have developed the PFAS effluent treatment system, a PET system, and basically it's a plug-and-play portable system that we can take on into installations to try out new technology. And we've done several pilot-scale PFAS remediations to support Air Force and Navy installations, including installations overseas. We're also taking advantage of sort of our 3D printing and advanced material development applications to be able to incorporate new materials for the sequestration and destruction of PFAS. And then finally, we have a lot of communication and tech transfer going on. We have a working group that's been established with US EPA, USACE, and industry focused on PFAS. We've been working with our European partners through the DefNet network and participated in PFAS workshops and sharing of information. There's a NATO workshop that's coming up late summer, early fall, being hosted by Denmark and Sweden. It's going to be focused on PFAS. And then there's an industry-funded effort to develop a framework that's sort of based on lessons learned from PFAS and other emerging contaminants to figure out how to improve our regulatory environment to prevent the future emerging contaminants. And with that, I think I'm on my last slide. Yep.
Okay, thank you, David. We're going to move to Dr. Igor Linkov. And Dr. Linkov, just a second. Dr. Linkov is the Senior Science and Technology Manager for USACE-ERDC and Adjunct Professor at Carnegie Mellon University. He's responsible for ERDC's project portfolio in the areas of crisis management and resilience. He develops methods and tools for measuring resilience in interconnected network and applies these tools to critical infrastructure, transportation, energy, and cyber systems, supply chains, and also to manage response and recovery following the COVID epidemic. He has several interagency committees and work groups that he's part of, including the National Nanotechnology Initiative. And he's also authored 25 books and over 400 peer-reviewed papers, book chapters, and top journals. He's an elected fellow with the AA Advancement of Science and Society of Risk Analysis. So Dr. Linkov, I'll let you take it from here.
Thank you very much. So my area is pathogens, and you may wonder why Army Corps worries about pathogens, but the reason is they're here to stay. COVID is not unique, and COVID shows to us that Army Corps is and will be engaged in crises of this magnitude. So the question is what we need, what we do. The challenge is, of course, we need to build infrastructure, and we need to have a place in this interagency group that address pathogens and build risk resilience. We, of course, we like to prevent pathogens and emergencies like we have with COVID from happening. But we clearly see that it's inevitable. And then the question is how we can recover and adapt. And this is notion of resilience that we start to build within Army Corps and other agencies in many fields, including for pathogens. But what can we do as an agency, and what help we may need from industry and academia? Well, for pathogens, we can measure or monitor, we can assess risk, we can model, and we can provide new technologies to address the issue. Technologies, it's quite easy. We have done it. We work on multiple technologies that provide decontamination. We're talking about foams, engineering structure for water treatment, air filtration traps. I think it's like a basic engineering and new technologies. We, of course, we use biotechnology that Ed mentioned to address more unique sampling strategy like RNA monitoring to address pathogens, and we can do it for COVID, of course. I will be skipping it because it's late in the game. On risk assessment and previous presentation, talk about that. What I like to highlight that for pathogens, you need to modify traditional risk assessment framework, and we are working on that in the context of both synthetic biology and microbial risk assessment and pathogens. There are unique features of these pathogens that needs to be addressed, and we are working on that, but more needs to be done. There are big gaps, and again, that may be collaboration potentials. Even before current pandemics, we were working on analytical tools and methods to address complex trade-offs across risk-resilient space for large-scale epidemic outbreaks. So this paper that we published back in 2018 for Ebola pandemics, but this type of modeling is still not done, and really proud that within ERDC we get mobilized about 1 year ago, and we develop models that are part of CDC Ensemble Forecast, and specifically my team developed another set of models that were used in New England region by FEMA and Health and Human Services. One of these modeling efforts that we're working on now with HHS and FDA, we try to look at vaccine and medical supply chains because we clearly see that design for efficiency that was implemented fails when you have pandemics or global crises like this one. And the question is how we as a government can ensure resilience in supply chain networks. So the last thing I like to mention, we live in the world when looking at one threat at a time is not sufficient. We clearly see that what we call compounding threats. We have projects now, we're looking at how we should implement crisis management tools that have been used for floods under condition of COVID. We cannot use the same models, the same methods, so everything needs to be updated. But even on the physical side, if you have compounding threats of flood and hurricanes and earthquake, or you name it, it may be, or socio-political crises on top of that, it may change completely the strategy that you implement addressing them. So yeah, that's all I have to say. Sorry for rushing it, but we're already 10 minutes behind the schedule. Thank you.
That's great. Well, I know that we're over, so I'm just going to try to summarize questions here. And this was kind of for the whole group. What can the SAMI community do to interface with and support ERDC? And I've got a couple questions here, so I'll throw them out and then we'll go from speaker to speaker real quick. Is there any change in focus? Well, yeah, and is there any change in focus, funding, or priority with the new administration? And then also, I know Tyndall was mentioned, and there's a question about Tyndall's being looked at as kind of a demonstration project. And one thing I know you guys were all talking about how you share information across the groups, which is great. And I know that it seems like that's what they're planning to do with Tyndall, is to try some new things and then maybe be able to implement those, across the broader Army program. So I'll start with those, and if we have a little more time, I'll go on from there.
Hi, this is Edmond. I can start with some of the leading questions that you mentioned.
Okay.
We have, a fairly set cadre of federal researchers that work for ERDC, but at times we do get surges in funding, whether they're congressional ads or otherwise, supplemental funding and so forth, that we need to be able to expand our capability and competency sets from time to time. We would do that normally through various acquisition strategies through our contracting division. There are many different instruments that they use to do that. You can go to BetaSAM, and if you have a DUNS number, you can query on opportunities that may come out through the ERDC contracting office. And we are looking to expand the tool sets that we would use in acquisition strategies to be better prepared for surge demand signals that we may experience from time to time, and sort of revolutionize our contracting instruments so that we're more agile and expeditionary to be able to turn those opportunities around. So those are a couple of things that you can be on the lookout for now and going forward into the future to partner with USACE and ERDC. Thank you.
Thank you.
Jane, this is Todd Bridges. In terms of kind of priorities, one thing we're seeing certainly an elevated focus on climate change and the need for the Department of Defense to have resilient strategies and solutions to address these kinds of challenges long term. Also, in the context of infrastructure, there's been over the last couple of years, and I think over the last several months even more so, a surging interest in what some might call natural infrastructure, what we would call nature-based solutions, or what I was presenting in terms of engineering with nature. In fact, in the FY21 budget, Congress gave the Corps a separate budget line on engineering with nature. We had been working that for 10 years, and that building up to basically a formal recognition of the program by that budget line being added. So we're quite excited about the potential to find these efficient solutions for the infrastructure challenges of the 21st century, and the Department of Defense, given the scope and range of the physical assets in the 19 million acres, or just about that we occupy. It really is 19 million acres of infrastructure, whether or not we recognize it as such, just because it's not vertically built. It's something that should be considered in the scope of our program. So those are some of the things that are getting additional attention and priority.
Okay, thank you. Did anybody else have something to offer there? Okay, another question. Oh, yeah.
I was going to say, this is David. I can't speak to the Tyndall situation, but I will say that, things that are happening in SynBio and in Igor's emerging pathogens group, certainly, this speaks to the sort of the crosswalk between the different programs and opportunities for sharing information as new tools get developed and their potential applications are realized. There's certainly opportunities, and we're trying to make each other aware of these new tools to be utilized under for different programs and different purposes.
Okay, and that was a question that we had too, is how you share information across the different either laboratories or disciplines. If one laboratory is working on a certain thing, but there might be an application to another laboratory, how do you guys communicate that from one group to the next?
Well, let me. Okay, go ahead, David.
I was going to say there are informal opportunities. We host things like Science Day internally across the ERDC, and so it's an opportunity for researchers to share what they're working on and the approaches that they're happening. So that provides some higher level of visibility across the ERDC, and provides opportunities for local networking. In addition, we have sort of programmatic reviews where, again, information is shared, and it provides an opportunity for researchers to see each other's work and facilitate those types of connections. I'll let Todd chime in.
Yeah, all I was gonna add, Jane, is that this is with the increasingly accelerating kind of information age. I mean, this is an ongoing challenge for really any organization, and the larger the organization, the more challenging it is. So we have over 2,000 staff members spread over 4 sites, working in the mind-boggling range of disciplines that we have in ERDC. This is an ongoing challenge for us, and I think we're looking for ways to use both, information technologies to help create that kind of networking dynamic, and as well as David was showing, the kind of face-to-face in person that you need. And at a broader level, it's how does one agency share with another? That's even another level. Or how does government and government agencies and work that we're doing, how do we share with the private sector? It just kind of compounds. It goes on and on. Forums like this that you're offering are useful, but this is its own challenge for all of us, and it's worthy of even discussion on this specific topic. How can we share what's emerging and with others across the organization, of divides that separate us?
Yeah, I think in looking at your, your bios and the programs that you're involved in, obviously you're interfacing with, public entities and other agencies and international. It's really interesting. Had two other, well, there's more questions, but two questions. One was for David on the portable PFAS remediation unit. Do you see that, being used as like real time? Can certainly understand it in the theater or, internationally, but in the US, would that be used if you see something, moving off site or increasing in a particular installation, or where do you see the application for that?
So short answer is yes, it's actually been used essentially for that purpose. It was, both as sort of a research project, but also to effectively address a contaminated retention basin down at Hurlburt Field. So they knew that they had elevated levels of PFAS in a retention basin that needed to be dealt with before they had a release, and we were able to deploy the system, demonstrate the technology, and at the same time effectively remove PFAS from that retention basin. And the other thing that they were able to do that generated interest at installations overseas. We developed a Connex-based version of this unit that was, sort of hardened for deployment, and it got shipped over there. And of course, this is about the time that COVID all came down. Originally, our researchers were going to travel to the site to set the system up and operate it, and they basically had to quickly switch gears and transition so that the folks on site, they had to train the folks on site to set it up and operate it, and it was a great success in being able to demonstrate how you could deploy something to an area and have folks that don't have any experience or understanding of the system and get them to be able to effectively operate it and utilize the system.
Right. Yeah, that's good. And I think Igor, probably with the pathogen side of it before the last year, we looked at pathogens as something that was, that wasn't on our doorstep. And probably there's a lot more focus on, on what you're doing and lessons learned for, not only combating the next strains of this, but applying lessons learned. Like you said, you can look at what we do in hurricanes or what we do in supply chain. It's, it's the same thing with trying to just apply it to a different stressor system with crisis management. So is that something where, do you guys work with like FEMA and some of those also just for lessons learned?
Yeah, absolutely. So Army Corps was tasked by FEMA to really build hospitals and vaccination sites. All those requires understanding of what's going on, how disease will be propagating and all that. Moreover, my team was directly mission assigned to FEMA to help them with modeling and data analytics. So there's all kinds of way Army Corps can be engaged in the pathogen world, but for military sites, I feel that even for our normal areas, we are now getting to be more and more integrated with kind of whole government approach, and the missions are now kind of diffused. We, in emergency especially, we may have to execute mission of other agencies if we are available, and for that we need to have right tools, right methods, basic understanding of what's going on. So I really feel we need to kind of get up to speed of what can be happening in the world of pathogens as it relates to our main functions. Over.
Okay. And then one question, because I know we're over, was just that with the engineering with nature and biotech advancements, do you see a place for the public-private partnerships, for natural resiliency and sustainability efforts? And then I was interested in the concrete sustaining sealant filler that's bacteria. And is that something you see being used on new fixtures, or would it be used on some of our aging infrastructure? Because we know that there's going to be a lot of dollars and a lot of eyes on how dollars are being spent there.
Right. So Jane, I'll start. This is Todd Bridges with maybe the first part. If Ed's still on, maybe he can address the second. But for sure, in my mind, more partnership and collaboration between and across the public and the private sectors is key to advancing infrastructure, and more than that, innovation and infrastructure. To that end, with the Engineering with Nature initiative, we started the Corps of Engineers with the University of Georgia, what we call the Network for Engineering with Nature last year. And people can just go to that site, Google it, or go to n-ewn.org to learn more about what this network is intending to do. And it's basically a virtual collaboration center that includes, the intent is to include government, academia, the private sector, and the nonprofit world, those interested in advancing nature-based solutions where we can kind of join together, share, and collaborate and leverage each other's activities to accelerate the advancement of capabilities in this space, but also their implementation. So I think it's key to progress. But Ed, are you still on?
Oh,
I don't. Yeah, he might have left. But you know, one of the aspects. Are you there, Ed?
Oh, no, this is Igor. I'd like to add on biotechnology if I can.
Oh, yeah.
Okay. Well, I was just going to say that materials, I'll just add that, you know, the material science world, there's clearly an interface between, you know, engineering with nature and advancement of materials, whether they're natural materials themselves or others. And I think this is a very exciting area of work and application to address things like aging infrastructure, but also how we can prolong the useful life of even newly constructed infrastructure. So there's all sorts of exciting potentials there, but I'll let Igor go.
Yeah, on biotechnology, public-private partnership is the key, especially in synthetic biology. I don't know if you're aware, but Biomate is like 300 or 300 million investment that done by DoD at 87 million, I believe, and then private entities specifically designed for biomanufacturing. We are currently engaged with Vicksburg school system on educational side of biotechnology. With one of this part of DoD modernization strategy is workforce, and we really paying a lot of attention for education. And even for this, we are teaming with school systems and industry like Ginkgo Biotechnology and other companies. So indeed, opportunities for public-private partnership in emerging areas are really growing and very important. Over.
Well, that's great. Well, I want to say thank you to all of our speakers and to Dr. Russo for pulling, this group together. It was a really interesting talk. And I know you guys are busy and you brought your top experts. So much appreciated. It was a great presentation. And then I encourage attendees to go to our SAMI Community of Interest website for environmental. That's where you can find the handouts and then also learn about when we have our meetings and hopefully join our environmental community of interest group. Thank you. Does Dr. Russo or anybody have any closing comments you want to make?
Yeah, thanks for the opportunity to engage your SAMI group. We appreciate that and look forward to future collaborations. Thank you and have a good day.
Thank you.